I need to get a new battery for my laptop.
The charger is the same, like the same arm having for it.
Yeah, but the battery's not charging, so if the cable falls out, it crashes.
Yeah.
It's not nice. Right, how was the potential divider?
Not easy.
Not easy.
First half was okay, but
Yeah, do you have the question there?
yeah.
Yeah, we'll get it done now in a second. You have it?
Yeah.
No, I mean you did it. Ah, how come? Ah, my heart. Alright, go ahead, Iyad, what have we got?
220 volt power supply.
Yeah,
This is right output voltage of 22 volts.
so you have 220 going in, and you would like 22 coming out. Gotcha.
We have 1 meter of copper wire,
Ah, yes.
thickness of 146 micro, 80 microamperes.
You have 1 meter of wire. Yes, got you.
Thickness 146
146 micro, like this,
Yes.
meters.
Yes.
So then that radius would be this over 2. Great.
This wire will be used to make the simplified voltage. The resistivity of the copper is 1.68 times 10 to the minus 8 ohms. How much resistance in the copper wire?
Okay, so step 1, this is a resistivity question. A or equals rho L over A, which equals 1.68 times 10 to the minus 8 times 1 all over pi 73 times 10 to the minus 6 squared. What? You couldn't be wrong already. What?
Why is R not D? It's D.
D
Yeah.
equals this, or equals this. A equals this.
No.
What do you mean no?
The D I change it to M.
Okay, yes.
Then I calculate the A.
Using this?
No.
Using what?
P multiply D over 2 square.
B?
No. P.
Pi
I, yeah.
multiplied by
D
D over 2.
and yeah, square.
But this is D over 2.
Same, yeah.
No, it's not the same.
Wait, hang on. Hold on, look. Wait, look. 146 divided by 2 is 73.
No, but I change it to M.
This should be the same
Times 10 to
answer.
the minus 6.
Ah. Oh my goodness.
Okay, what's your answer?
Yeah, what's your
What's your
answer?
final answer?
1.01.
Yeah, okay.
Same, is it?
Yeah. It's 1 over, yeah.
Hmm. Yes. 1.003. So basically 1 ohm.
1 ohm.
Yeah.
Another way to.
Yeah, another way to do it. Yeah. Okay. Yeah. What's the B part now?
The copper wire is turned into 2
Yeah.
to make 2 resistors. So how much resistance in each resistor?
Okay. So what you have here is you have a R1 and then an R2, and here you have a 22 volts. So you want 22 here. So we can use our formula from the class. If I remember correctly, it's V out equals R1 over R1 plus R2 times,
R2 in the denominator.
oh sorry, it's R2 on the top?
Yeah.
Five.
Yeah, sorry, R2, thank you. And then V in Now actually, I know what R1 plus R2 is.
1.
It's 1, very good, because if you have the copper wire and you're cutting it in two, the total resistance will still be 1. So you get 22 equals R2 times 220. So, yeah, over 1, yeah. So R2 equals 22 over 220, which is 0.1. Which means R1 will equal 0.9 ohms. The question was how much resistance in each of this. Okay. Is C, what's the length? I'd say so. That seems like what I'll do next.
How long?
Yeah. So you have R equals rho L over A. So then A equals, L equals R A over rho. So what you can say then is L1 equals R1A over rho, and then L2 equals R2A over rho. This A is the same, this is the same, this is the same, this is the same. Here R1 is 0.1, and here R2 is 0.9, and this one's 0.1. I won't do it. You put the numbers in, and this will become 0.9 meters and 0.1 meters when you put in the A. The A and the rho are the same as here.
Is it a coincidence?
No, I made the question so that that would happen by coincidence, but it doesn't normally happen like that. I did that on purpose. Okay, so what's the next part then?
A 10 ohm large resistor is connected in parallel to the output.
Yeah,
What
so
is the voltage?
So here we have R1, which is 0.9, and then here we have a, what's it, 0.1, and you said a 10, was it? Great, and we want the voltage across now. So this together needs to be added. 1 over 10 plus 1 over 0.1. And then flip that around, and we get this new R2 is 0.099. Yeah, so now V out will be 0.099 over 0.9 plus 0.099 is it nearly, yeah. Which will be, yeah, 0.0991. No, sorry, and I forgot to multiply by 220, yeah. 21.8 volts. Okay, what's the next part?
The volt in part B is not 22.
Yes.
Why?
Yeah, well, it's because R2 changed. R2 changed from, what was it, 0.1 to 0.099 ohms. Okay?
Adjust the length until the voltage through the large resistor is 22 volts. For
Right. So R1 is here. I'll call this R2, and this is R3, but together they're like the R2. We know this one is 10. So I need to add these together. Anyways, we know that 22 is here times 220 all over R1 plus, and then on the top it's this one. So I need to add these together, okay? It'll be 1 over R3 plus 1 over R2. This will be R2, R3, R2 plus R3, and then I have to flip that upside down. So it'll be on the top here, R2, R3 over R2 plus R3, and then here the same thing. R2, R3 over R2 plus R3. I know, it's messy. Also, we know that R1 plus R2 equals, 1. 1. Because you had 1 ohm to begin with. Now, that's a pain, right? That's a pain. But there's a little trick that you can do here. So you can see that solving it this way is going to be quite difficult. In fact, nearly impossible. But watch this little trick on the side here. This is R1, and this is R2, and then this is in, and then here is out. So you know, remember that V out equals, what do we say, R1 over R1 plus R2.
R2.
I keep making that mistake, I'm so sorry. Over, and then times V in. Yeah. So then you can say V out. Let me think which way I want to do this. Yeah, V out over V in equals R2 over R1 plus R2. So V out ratio V in equals R2 ratio R1 plus R2. So what I'm saying here is, if this, let's say this compared with the total is something like 1 ohm compared, let's say the total is 3 ohms, then I know the output voltage and the input voltage, they'll be in the same ratio. What I'm trying to say is the relationship here and here is the same as the relationship between, this one and these two. Now, I don't know, that you might find that a bit more helpful. So like what I'm saying is, the relationship here with this one, this one with the total is the same as, where's it gone, 22 to 220. So in other words, what I'm trying to say is there should be a 10 to 1 between the two of them. One should be 10 times bigger, or I suppose you could say one should be 10 times smaller than the total. So in other words, R1 should be 1/10 the total, of these added together. I don't know. I'm starting to feel like maybe I made this one too difficult. Is there a part after this?
Yeah, well, this is a question myself, and then you have like part B of that part. So it's a bit different.
What's part B about?
The links are changed to 0.1 and 0.89, and then what's the voltage, what's the power, what's the current?
Yeah, I think I made this too difficult now. For the exam, it's only going to need to go to this far. I should have stopped here. I did this one last year, and it was difficult last year. I don't know why I thought it'd be any easier this year. I think I made it too difficult for you. Do I want to do it? Let's see. R1 plus R2 is 1. Well, I suppose the other thing is, you also know, if you want to do it as an equation, you also know that R3 is equal to 10. Shall we just see what equations we can make, how ugly they are? We don't have to solve them. Let's just see what we can make. R3 is equal to 10. So we have now 22 equals 10 R2 over R2 plus R3. 10 over 10, of course, not 0. All over R1.
R1 we can put in.
We can, use this one, yeah. Did you do this one?
No. But I know how to do it.
Yes, me too. R2 and R3, that's 10 R2 over R2 plus 10. But like Fuang said, you can say that OR2 equals 1 minus OR1, which you can put in here. And we can call OR1 x. So we have 22 equals 10, 1 minus x over OR2. Yeah, OR2 is 1 minus x plus 10 all over OR1, which is x, we said, plus 10, 1 minus x over OR2, which is 1 minus x plus 10. So you just have to solve this. That's all you have to do. Now actually, you know, it isn't actually as bad as it looks once you start putting things together. Let's see, we have 20 equals 10 minus 10x over 11 minus x divided by, and then we need to put this together. So let me just put this down. That's a 10. 10 plus 1 is 11 again.
Yeah.
11 minus x. And then we have this one times this one. So that would be x times 11 minus x plus 10 times 1 minus x. So that would be 10 minus 10 over x over 11 minus x divided by 11 minus x over 11x minus x squared plus 10 minus 10x. Cancel, cancel.
Wait.
What do you mean wait?
Yeah.
What?
Ah.
10 that over that, then we have minus x squared, minus 10x plus 11x, minus x plus 10.
Yeah.
So cross multiplying minus 20x squared minus 20x plus 20 equals 10 minus 10x. Taking everything to the right.
9 plus 200.
You're giving me...
The C is 200.
Thank you, 200. 20x squared...
Plus 10.
Plus 10, what, here? Oh, you're telling me what's next, sorry. Plus 10x minus 200 equals 0.
What about 10?
What about 10? Oh yeah, sorry.
That is 10.
210?
Minus 10x.
Ah,
190.
190.
Yeah.
Thank you. 2x squared plus 10x minus 19 equals 0. After all that pain...
Oh.
Nice. So you get
1.5.
x equals 1.468, blah, 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 and then minus 6.468. So I've made some mistake. Because, why?
Minus.
Because the X
Well, the
is
minus-
1 point bigger than the R1 plus R2.
Yeah, exactly right. I only have 1 ohm to begin with, so I've made some mistake here. But anyways, I just wanted to show you the way I would think about doing this one. And then once you have the resistance, you can get the length. This worked last year when I did it, so you can watch the video from last year if you wanted. What's the next part?
The lengths are changed slightly to 0.1
Yeah.
and 0.8991. What is the output voltage now?
Is that the last question?
Well,
No,
part B
last.
and it has 5 questions.
What? What did I give you so much for? Alright. Really? Really? And what's the next part?
What is the power output of the large resistor?
Yeah,
What
next.
is the current divided by the frequency volts?
Yeah.
What's the power input and how efficient is the potential?
Goodness sake. Alright, yeah, okay, let's go on. So, sorry, what did you say the OR1 was? Let's just do it quickly.
0.1009.
0.1009 and then OR2.
0.8991.
And then, sorry, OR1 and OR2.
Yeah.
And what do I ask you now? What's the V out?
No, this is not R1 or R2, these are the lengths.
L1 and L2.
Yeah.
And what do I ask you?
What's the output voltage?
Okay, so first you have to calculate the OR1 and the OR2, but because of the way I chose the numbers, when you put them into the formula,
It's going to be
it's going to be the same. Now that doesn't always happen, but I gave you a little bit of a break by making at least that easy. And the A is what's the output voltage? So V out, well, you know what the story is. OR2,
L1, not equal R1, how I...
You have to use this formula, or equals rho L over A.
But the A and
No, this is the same. It's the same wire.
The L.
Yeah. It's only the L that's different, yeah. So we have 0.1009. Well, I suppose this should still be 1. Sorry, that should be 220. What did you get for 1? 197?
Yeah.
Yeah.
By 802.
Yeah. Okay, what's the next part? Yeah.
Power output of the losses.
So the power output, and you have the 2 resistors. So the large resistor is R2. So what formula do we want to use for power? Well, we have IV, don't we? And we have our VIR triangle. Now, we want to try and get OR in here. Wait, do we know the I? No, but we know the V, so we don't know the I. So we should replace the I with V over OR.
Yeah.
So that's V squared over OR.
Yeah.
And the R2 we know it, it's right here. The V we know, sorry, and the R we know. So yeah, okay. It'll be 197 squared roughly over 0.8991. So this comes out, power is 43516 watts.
for R2?
Yeah. What's next?
What's the current?
Alright, so now we can say the current is P out over V, if I just rearrange this. So my answer I just have divided by 197.802.
Why the power
Is that not it? 197 squared over 0.8991? No? Oh, sorry. No, it is.
Yeah, it's not.
43164.
I don't know. I used 197.802. I just wrote 197 here. I used all of this.
Ah.
Yeah. What's the next part?
What's the power input?
Power input. Power input will be.
All of this for R2.
Yeah, now this is still R2. The power input now is here. Right, so we could use the same formula, V squared over R. Yes? Yeah, we could use the same formula because the V squared is going to be 220 volts. But the OR, what's the OR here?
But it is 197.
No, this is the volts, input volts, V in.
2.8
This is V in, not this is power out. Sorry, this number here is the current. It's just 220 by coincidence. Yeah. V in is 220, isn't it?
This is the current is 200.
Yes, and also the voltage is 220. It's a coincidence. You know what I mean?
Yeah.
You know this word coincidence? Are you sure? Give him the Arabic of coincidence just to make sure. Yeah, okay, just a coincidence. So it's still 220 for Vn. And what's the OR here? No, because you're looking at the total.
So it will be 43516.
That's the power. It's 1. Because it's R1 plus R2, which is 1. So the power in is 220 squared, which is 48400 watts. Yeah. So then the last thing is the efficiency. And the efficiency is power out over in times 100. Yeah. (89.9% efficient). What? It's a hard one, I know, but it was the end of the chapter and I kind of wanted to put a lot into it. I guess that's why I made it so hard. The only thing that was missing from this is Kirchhoff. Then it would have had everything in it.
Well, you said you may use Kirchhoff's rule.
Did I?
Question 4, yeah.
Cool. So I got everything in there. Alright, that was a hard one. That was a hard one. And probably harder than what you need for the exam, but like I say in maths class, it's good to do things a little harder than the exam for studies, because then the exam will seem better. Huh?
You just said that in the math class.
Yeah, that's what I'm just saying. I say the same thing in maths class. That it's good to do things a little harder than the exam. It's better for your preparing for the exam. Yeah, this is a hard one. I know it was, but for the exam, it probably would only be as hard as where I marked stop earlier. Do you remember?
Yes.
Yeah.
Well, part B counts, doesn't it?
Part B does, yeah. I just remember that whole thing of finding the x.
Yeah.
That's way too hard
That
for.
one,
Yeah,
yeah.
yeah. Maybe I'll mark that question as very difficult. Or maybe I'll just give you the answer next year and then you can skip finding the x. Yes, no? Good. So take your jacket off then. Okay.
It's not my skin dry.
Do you have moisturizer? No, that's sad. Right, can we continue? Yep. So we're finished the electricity. Yeah. So
Talk about a little